students. I'm coming to you in this video to tackle one particular question that was asked on a recent exam. And the question is, the sound intensity level 5 meters from a point source is 95 decibels. At what distance will it be 75 decibels? So a person is 5 meters away from a point source of sound, and the person hears an intensity of 95 decibels. And at what distance will the same person hear an intensity of 75 decibels? In order to find this, we need to know the definition of intensity of sound. Intensity of sound is actually the power divided by the area. So what you have here is a source of sound right at this point, and the person who is listening to the sound is at this point R1 meters away. Now from the source, sound actually propagates in all directions, and so it's going to move out in the form of spheres. I know I've only drawn circles here, but actually it's going to be 3D and it's going to propagate in all directions as a sphere. So that's what, and the person receives a small part of that, the sound that is reaching him. On the other hand, if the person moves further away and is now at a distance R2, then he's going to hear even smaller intensity, because the sphere becomes bigger. As you can see, the sphere is bigger here, and it's only even a smaller part that reaches him. Therefore, it's the surface area of the sphere that comes into play, the surface area of a sphere. And the surface area of a sphere is 4 pi r squared, 4 times pi times the radius square of the sphere. That is why when you take the ratio of the intensities at A and at B, when you take that ratio, it's going to be inversely proportional to the square of the distances or the radius. So here we are, I1 by I2 is going to be R2 squared by R1 squared. So that's the first thing that we need to know actually when we talk about the intensity of sound. And the second thing is that we need to know that the intensity of sound is measured in 2 units. One is a conventional unit. The other is the actual unit in the International System of Units. The unit in the International System of Units is watt per meter squared, but the practical unit is decibels. So now we need to know how to change from one to the other, right? And that's where this formula comes in. Beta in decibels is 10 times the log of I by I naught, where I is the intensity in watt per meter squared. And we're trying to change that into decibels. Now, I naught is a constant. It's called the threshold of hearing. That means the minimum sound that is perceivable, the minimum sound that can be heard by a listener. It's 10 to the negative 12 watt per meter squared. And when you do the math, if you put the intensity of sound as 0, actually, if you put it as 10 to the negative 12, then you're going to get both as 10 to the negative 12. So that will be log of 1, right? Log of 1 is 0. So 10 times 0 will give you 0. So if I is 10 to the negative 12, in decibels, you're going to get 0. So that's what this table represents. This table actually shows you that if you have 10 to the negative 12, you get decibels 0. If it's 10 to the negative 11, then you get 10 decibels. 10 to the negative 10 becomes 20 decibels. So you see how the relation works. And when you get to 1 watt per meter squared, which is here, 1 watt per meter squared, then it becomes 120 decibels. Actually, that's called the threshold of pain. that's about the intensity at which rock music is often played. So that's the threshold of pain. So you have the threshold of hearing and the threshold of pain. All right, having said that, now let's get back to our question, all right? So here's our question again. The sound intensity 5 meters away is 95 decibels. At what distance will it be 75 decibels? So the two things that I told you, we're going to use both of them to work out this problem. So first, remember the formula, beta is 10 log I by I naught, where we have 95 is the first intensity that is heard. So we're going to change that into watt per meter squared into the actual system of units. So we're using this formula. And then 95, I'm bringing this 10 to the other side. So that's why it's 95 by 10 is log I by 10 to the negative 12. And then 95 by 10 is 9.5. Then you have log 10 to the negative 12. So now to get rid of the log on the right side, on the left side, we have to do 10 raised to, because those are opposite functions, right? So log to the base 10 and 10 raised to are opposite functions. So instead of writing log of something here, we can write 10 raised to that. So 10 raised to 9.5. So notice there is no log there. And then rearrange that. When you rearrange that, this will go to the other side. So you will have 10 to the 9.5 times 10 raised to negative 12, which is going to give 10 raised to negative 2.5 watt per meter squared. So 10 to the negative 2.5 watt per meter squared. So now we've changed 95 decibels into watt per meter squared. Let's do the same with 75 decibels. And I'm not going to write the whole thing again. We can just take it off from this last step here. I2 is 10 to the 7.5 because it's 75 decibels. We're going to get 7.5. So we get 10 to the negative 4.5 watt per meter squared. So that's what you get for the second one. So now that we have got I1 and I2 in watt per meter squared, now you can use the idea that the intensity is inversely proportional to the square of the distance. So now I1 by I2 is R2 squared by R1 squared. And then we substitute the values. That's a calculation mistake that I made. So simple math errors. So we end up with that. And then all we got to do is make R2 the subject, right? So what do we have here? In this case, when this goes to the top, it's going to become plus 4.5. So you have 4.5 minus 2.5, which is 2. And then 25 comes over that side. So that will be 25 times 100, which is 2500. Okay, so here it is, 10 to the power 2 times 25 is equal to R2 squared. And so to get R2, you take the square root of 2500, which gives us 50 meters. So I hope you understood how this problem has been worked out. So there are two important things that comes along in this problem. First, we have to change decibels into watt per meter squared. Second, we have to remember that intensity is inversely proportional to the square of the distance. And when you combine these two ideas, this problem is worked out. Thank you. I hope you enjoyed this video.